We are a children's science center. We like to use the term museum sometimes, but we're not a typical museum. Everything that we do here is hands-on, not a whole lot behind glass cases.
I guess the first thing we really did was get to know each other a little bit and meet with the customer. That was most important, is figuring out what the customer needed, because it's not about how we want to design it, it's about what they need.
We picked a project that we've been wanting to do here for a long time, this pneumatic tube, where we show principles of air movement and air pressure, and we wanted to do it in a fun way.
So the original objective was to have air push objects through a path, and since there was going to be two paths, one for the interactive objects and one for the donation, we chose to do the one fan and the valve, and the valve took the form of our diverter box. So the diverter box uses a linear actuator on the track, which moves carriage back and forth.
One of the early weeks, the first thing we had to do was build what we like to call the jungle gym structure.
The idea was to get some Schedule 80 PVC pipe, which was very rigid, which would be able to support the tubing.
If you wanted the track to go one direction, you had to use one T with another T on top of it to go 90 degrees in a different direction. So we ended up using really unique heights, and we used middle filler pieces to get it to the right height.
We cut down all the tubing using the horizontal bandsaw. Then what we did is we glued it together using a primer to better adhere the liquid cement to the PVC piping, put it in so it really adheres in there. You can't take that out once you apply it.
Once we got it built, the different angles, the different heights looked really neat, and it made it look a little more interesting than just a plain square where everything's at the same height.
The code for the most part was based off of C code, which I've used in a lot of my classes. The thing with microcontrollers in general is just about every type of microcontroller has its own specific format for coding, so it was just a matter of getting adjusted to the coding for the Arduino microcontroller. So once I got a handle on how they did things with just defining variables and defining pins, it was pretty much straightforward.
And here's the demonstration. This is drop point 2 being connected to ground to activate the linear actuator. It'll be on for about 4 seconds and it will shut off. There it goes. Now I'm going to move this to the fan. The fan is activated.
Once the drop point 1 button is pushed, it activates the linear actuator to go in the path of the drop point 1. Then it will turn on the fan for about 30 seconds so that it can ensure that whatever object is put in the drop point gets through the whole tubing. Then after 30 seconds, it'll shut off.
What I was most concerned about is I'm not very hands-on. I have a lot of, the analytical experience, but not so much the construction experience. But my teammates were great. They took the time to teach me. They made sure that I got to turn with the tools, with the machine, whatever it was. One of the jobs I was given was to bore out the inside of the couplers we were going to use. We put the track into segments for easy troubleshooting. We needed a way to connect them. So we ended up taking out the inside diameter of a bigger piece of coupling.
I think the coolest part about my role is I'm able to capture, using film, the progress of the project from being just a plank of wood and a few PVC pipes to a finished product.
Okay, so we have this vision, we have this idea for a gadget, right? But we don't really know yet if it's going to work, if it proves that principle, that air movement thing, and if it's fun and interactive so kids can really relate to it, right? So if we can prove all that through a development of a prototype, then it makes the next stage project so much easier. We can scale it up.
It's really neat the way we have it set up. A lot of loops and a lot of different paths going around. So
I enjoyed doing this project for the Discovery Space. I'm happy to see a small organization compared up with Penn State.
I'm glad of the outcome. I feel like we've accomplished what we've, started to do, or what we set our goals to be.
This project is for a local children's museum, so that's really exciting, knowing that what we're doing is going to spark interest in younger children to get into the engineering field or the science field or the math field.
So again, what we were hoping for, and what apparently is happening, is that the first stage and the early scale pilot stage will prove that concept, and it does work.